Hey guys, today we're going to take a look at two special cases, or two sort of fancy ways we can factor. And the idea behind these is just they're, faster ways to square root or to factor some very specific cases here. You'll notice I've already started the video, wrote some stuff down, and didn't work out, so I am restarting here, so bear with me. But anyway, the first one is called the perfect square. Now this one is not as great as the second one I'm going to show you, partly because a lot of the times you just don't notice that it is a perfect square, and so you end up doing it the long way. But the good news is, if you don't notice, you do it the long way, you're going to get the right answer anyway, so don't worry about it. So hopefully you do notice, and here's the tips. So first of all, what is a perfect square? A perfect square is going to be anything that has a simple square root. So if you square root it, you're just going to get a very straightforward number. There's no decimals, there's no fractions, anything like that. Now I do think it looks like I spelled square root wrong, because square root is two words. So we'll split that up. But anyway, there we go. So 25 is a perfect square because square root of 25 is 5. Square root of 4x squared would be 2x squared. Well, no, the square root is just 2x, so and so on and so forth. So these are our perfect squares. And so the numeric ones, you can just go through and you can say, well, what's 1 squared? It's 1. What's 2 squared? It's 4. 3 squared is 9. And we could continue. We get 16, 25, 36, and so on. Okay? And so, don't be afraid to try. If you suspect something's a square root and maybe the number's a little bit bigger than you're used to, maybe it's, 121 or something like that, and you're like, maybe that's a perfect square. Just try it on your calculator and you'll find out. So, here's a table of perfect square trinomials and their factors. So the first one here is x squared plus 12x plus 36, and that's going to give us x plus 6 times x plus 6. And so you can see the secret here is that if you look at this a value here on all of them, okay, that a value there, it doesn't matter which one you look at, it's a perfect square. So 16 is a perfect square because 16 is 4 squared, 9 is 3 squared. Okay, 1, this is an important one because people often miss it, 1 is 1 squared. Okay, 25 is 5 squared. And if you look at the c value here, well, 49 is 7 squared. Again, 9 is 3 squared, and so on. And so on and so forth. So the first number, the a value, and the c value are going to be perfect squares. So that's the first major hint. The first major hint that these are going to be perfect squares. So we'll just write a and c are perfect squares. Perfect squares. All right. So, unfortunately, the b term, or this term in the middle, you see right there and there and there, it also has to be a very specific value. If we have the wrong b value, it doesn't matter if the a is a perfect square and the c is a perfect square. It might not be a perfect square. So what we're going to do is we're going to check that value, and it's not as easy as it sounds, but it's not super hard either. So this is another reason that sometimes people just ignore this method, because sometimes it's just easier to do the normal one. But here we go. So the first one here we've got, so this one here, if we were to factor it, it gives us 5y plus 2 and 5y plus 2. Well, that is, of course, a perfect square then, because this guy right here and this guy right here are equal. However, this other one here, well, the 25 is a perfect square, 4 is a perfect square, but if we factor it, that is not equal to that, so that is not a perfect square. So the secret here is what we need is we need this b value to be equal to 2 times the square root of a times the square root of c. So if we jump over here, well, we take that 20, okay, Well, our A value is 25, our C value is 4, right? There's 25 and there's 4. So if we square root the 25, we get 5. We square root the 4, we get 2. 2 times 5 times 2 is 20. So yeah, that is a perfect square. Second one though, when we do same idea, we've got A is 25, C is 4, so we've got 5 and 2 again. 2 times 5 times 2 is 20, but this one here has a 25 in the middle. Our B value is 25, so that is not a perfect square. Okay, so that's how you check. If you do notice this, and again, it's almost always the case that if you find that that A value and that C value are perfect squares, it probably is going to be a perfect square, just because, you know, that's just usually the way it works out. Okay, so if you notice, do a quick test, try that B value, and if it is a perfect square, the good news is it's going to be really easy to factor this. Okay, so that's why it's worth checking. I'll do the first one with you here, and then I'm going to have you do the rest on your own. But, so yeah, so first we go through, we say, well, 1 is a perfect square. Remember, there's an invisible 1. 16 is a perfect square, because the square root of 16 is 4. So we've met the first criteria, so now we need to look at this guy right here. So we say, well, the square root of 1 was 1, square root of 16 was 4, so we have 1 times 4 times 2, and it gives us 8, which means, yes, this is a perfect square. Okay, so what we're going to do then is we're just going to take the, I should have left this blank and then I could just write it out, but what you're going to do is you're going to take the square root of this A value here. You're going to take the square root of that, which was 1, and you're going to put it in the front of your brackets. You're going to put it in the front of that bracket too. And then you're just going to take the square root of that one, you're going to put it at the back of the bracket, and the back of the bracket. And then the only thing that's left is you do need to look at this sign right there. That one's a negative, and that's why we know to put a negative there and there. Okay. So let's do this next one here. So first of all, square root of 16 is 4. Okay, so that's a check. Square root of 25 is 5, so that's a check. So now we say, all right, well, what's 2 times, and we say square root of 16 times the square root of 25. So we got 2 times 4 times 5. 2 times 4 is 8. 8 times 5 is 20. 40. Whoops. There we go. 8 times 5 is 40. And look at that. It's perfect. All right. So what are you going to do? Well, the next thing we have to do is we have to look at that 40. We have to say, well, that's a negative. So we'll write negative in here. Okay. And so now we're just going to write down our answer, because this is the thing. I mean, that was the hard step. Figuring out that it was a perfect square was the hard part. Now we do the easy part. We just say, all right, well, the first one was 4. So we put a 4x in. Square root of the 25 was 5, so we put a 5 in. It was negative, so we put a negative in. And that's it. That's the answer. Okay. So anyway, so there's sort of a trick you can use. I do want you to try it out and try and get used to it. I want you to try these other ones, and then we'll take them up in class. But I'm going to jump over to the much more useful difference of squares. Okay, and this is something that you use over and over and over and over. And it starts almost the same way, but it's actually much easier to identify. Primarily because it's a binomial, not a trinomial. There's only going to be 2 terms for this to work. Okay, so a difference of squares is actually a difference, which means subtraction, of 2 squares. That's why we call it difference of squares. Okay, so first of all, it's a binomial with 2 perfect squares on either end. The other thing that's important, so just like before, this first term had to be a perfect square, the second term had to be a perfect square, but unlike before, the only other thing we're looking for, that middle, instead of having to do that complicated stuff with the b value, you just look, and all we need is a minus there. Okay? If there's a minus there, and you got those two perfect squares, you know right away it's a difference of squares. Okay? So how do you do it? Well, this is even easier because we just take the square root of that starting term and the finishing term. We just write it in the front and back of the brackets, and then you just give one of them a plus and one of them a minus, and that's all there is to it. That was a lot quicker to explain. So if we look here, this one here, square root of 4 is 2, so we're good. Square root of 1 is 1, so we're good. Is there a minus? Yes, there is. So is it a difference of squares? Yes, it is. So we just take the square root of the front and the back, put it in the front and the back, give one of them a plus, one of them a minus. Order doesn't matter. Okay? So let's actually do one here. So we've got p squared minus 9. Well, the square root of p squared, or 1, because remember there's a 1 in the front, is a 1. Okay, so right there, boom, first step done. Square root of 9 is 3, boom, there we go. And finally, is there a minus in between? Yes, there is, so yes. So now all we have to do is we say, what's the, we were right at our brackets. I don't know why I'm using red. Oh well, I'm gonna switch to green. No, green's ugly. Let's go blue. All right, square root of p squared is p. So you put that in the front. Square root of 9 is 3. Then we give one of them a plus, we give one of them a minus, and we're done. And that's all there is to it. So that's a difference of squares. So I want you to try these next couple, and then we'll take them up in class too. All right, so until next time, go Sabres.